Hey everyone, welcome back to Roboarmy.
This time, we have got a super useful project for robotics beginners and robot arm enthusiasts. A 5 servo motor controller using an Arduino Nano Expansion Board and push buttons. This project can also be used as a basic 3D printed robotic arm controller, where each servo motor controls a different part of the robotic arm. So let's get started. Here's what we will need for this project: Arduino Nano Expansion Board, 5 servo motors, 10 push buttons, breadboard, jumper wires, USB cable, external 5-volt power supply, 3D printed robotic arm parts, servo horns and screws, robotic arm gripper or claw. You can find the Arduino code, circuit diagram and 3D printing files for the robotic arm in the description box below. Now let's start by setting up the connections. Installing the Arduino Nano. First insert the Arduino Nano carefully into the Nano Expansion Board. Make sure all pins are aligned correctly before powering the board. Before connecting the servos, let's quickly assemble the 3D printed robotic arm parts. Place all servo motors in their correct position on the robotic arm structure. Now servo 1 will be used as the base servo, servo 2 will be used as the shoulder servo, servo 3 will be used as the elbow servo, servo 4 will be used as the wrist servo, servo 5 will be used as a claw or gripper servo. Fix the servo motor using screws according to your 3D printed robotic arm design. Connecting to servo motor 1. Connect servo 1 signal wire to D3 on the Nano Expansion Board, red wire to 5V, brown wire to GND. Now place two push buttons on the breadboard. For the first button, connect one terminal to the breadboard rail and then connect that rail to D4 of the Nano Expansion Board. Connect another terminal to the breadboard GND rail. For the second button, connect one terminal to the breadboard rail and then connect that rail to D2. Connect the other terminal to the breadboard GND rail. These buttons will control servo 1 in both directions. In our robotic arm, servo 1 works as a base servo. So when we press this button, the base of the robotic arm will rotate clockwise and anti-clockwise. Connecting servo motor 2, signal wire to D5, red wire to 5V, brown wire to GND. Place two push buttons on the breadboard. First button, one terminal to the breadboard rail connected to D7, other terminal to GND rail. Second button, breadboard rail of one terminal will be connected to D8, other terminal to GND rail. In our robotic arm, servo 2 works as the shoulder servo. Connecting servo motor 3, signal wire to D6, red wire to 5V, brown wire to GND. Place two push buttons on the breadboard. First button, breadboard rail of one terminal will be connected to D12, other terminal to GND rail. Second button, breadboard rail of one terminal will be connected to D11, other terminal to GND rail. In our robotic arm, servo 3 works as the elbow servo. Connecting servo motor 4, signal wire to D9, red wire to 5V, brown wire to GND. Place two push buttons on the breadboard. First button, breadboard rail of one terminal will be connected to A0, other terminal to GND rail. Second button, breadboard rail of one terminal will be connected to A1, other terminal to GND rail. In our robotic arm, servo 4 works as the wrist servo. Connecting servo motor 5, signal wire to D10, red wire to 5V, brown wire to GND. Place two push buttons on the breadboard. First button, breadboard rail of one terminal will be connected to A2, other terminal to GND rail. Second button, breadboard rail of one terminal will be connected to A3, other terminal to GND rail. In our robotic arm, servo 5 works as a claw or gripper servo, so when we press these buttons, the claw will open and close. Power connections. Since 5 servo motors can draw significant current, we recommend using an external 5V power supply. Connect power supply positive to expansion board 5V rail, power supply negative to expansion board GND rail. Also connect the breadboard GND rail to the Nano Expansion Board GND. Make sure the Arduino Nano, breadboard, servos and the external power supply all share a common ground. Before powering the system, carefully double check all wiring connections with the circuit diagram to ensure everything is connected correctly. Also make sure all servo motors are fixed properly on the 3D printed robotic arm structure and the servo horns have enough space to rotate freely.
Roboarmy. One-stop global community for teens in robotics and AI.